All right, so example 7, we're kind of doing things symbolically. It says, suppose that differentiable functions f and g and their derivatives are given below. Now, as soon as we read differentiable, we know that means that the functions f and g are also what? A differentiable function, continuous, good. So that comes for free with the fact that they're differentiable. So we have some columns here, 5 columns, 3 rows. Values of f, g, f prime, g prime at 2 values of x, namely 2 and 3. So we can use that to evaluate the derivatives of the following expressions at x equals 2. Now, because these are expressions, notation is going to be kind of lacking. So here's what I'm going to do. I'm just going to call each of these things y. It makes it a little bit easier notationally to take the derivative. So I need to find the derivative of this at 2. Now notice it's not a polynomial, it's not sign, it's just function notation. So we can take the derivative symbolically, like we learned way up here when we first learned the chain rule, right? The derivative of f of g is just f prime of g times g prime. Okay, so let's set out to do that then. The left side becomes y prime, or dy dx. The 2 in the front goes along for the ride, right? Constant multiples are there in the beginning, there at the end. So we have f of blob. What's the derivative of f of blob? F prime of the blob. I'm going to write that as 3 halves x, and then times the derivative of the blob, which is what? 3 halves. Good. Now, because we want to plug in a 2, which means we're using it, let's go ahead and simplify. This 2 and this 2 divide out, and we're left with 3 times f prime of 3 halves x. And now to show that we're plugging in a 2, we'll either put y prime of 2, or if you happen to use Leibniz notation, here's what it would look like. It's a little fancier looking. dy dx evaluated at x equals 2 with that vertical bar. And now we just plug in a 2, and we get 3 times f prime of 2 times 3 halves is 3. So we haven't used the table or the chart yet, but now I think to get past this step, I need to. So we go up to the chart and we look for f prime of 3, which is 2 pi. So if I replace that with 2 pi, we get 3 times 2 pi, which is 6 pi. And there's the answer. Okay. Excellent. All right. Part B, f plus g. So let me call that y. I need to find y prime first. So that's just easy. That's just f prime of x plus g prime of x. And now I can plug in my 3. So y prime of 3 is f prime of 3 plus g prime of 3. And now I can just work straight down, putting the equal sign, and then I go to the table. So f prime of 3 was still 2 pi. And g prime of 3 is 5. And that's about as good as we can get because 2 pi and 5, although they're both constants, are unlike terms. All right, part C, y equals. Now, if you're not plugging in, you don't have to carry along the of x every time you take the derivative. I'll show you on this one. The left side, I'm going to use dy dx this time. What rule do we use on the right? F times g, product rule. So that's f prime g plus f g prime. So that's where I mean you don't have to put the of x. You would get credit for the derivative. And then to evaluate it at 3, dy dx, evaluated at x equals 3. Here's where you would either go to f prime of 3 times g of 3 plus f of 3 times g prime of 3, where you need the of now. Or you could actually skip that step and just go straight to pulling values out of the chart. That would be fine too, as long as the values in the chart are visible when you plug them in. You would still need to put dy dx evaluated at 3. So f prime of 3 is still 2 pi. G of 3 is negative 4. F of 3, this part is not difficult, but it could be very easy to make a careless mistake and pull the wrong value out. G prime of 3 is 5. So from there, we get 15 minus 8 pi. If you want to simplify it, I lead with a positive term there. 15 minus 8 pi. So you could go straight from, well, we'll do it on the next one. All right, so the next one here is f of x divided by g of x. We'll call it y. So we get y prime equals, and here's where we could again do it without the of x. This is the ho d high rule. So ho d high is f prime, minus high is f, d ho is g prime, all over ho ho is ho squared. Now from here, if you want to, you do need to show y prime of 2 on the left. But if you can, just pull the value straight off of the table, that would be fine. So let's do that. Let's see if we can do that. G of 2 is 2. Here's where the values from the table, though, would need to show up. So don't try and simplify it in your head as you write it down. F prime of 2 is a third, minus f of 2 is 8, and then g prime of 2 is negative 3. And then g of 2 is 2, and instead of squaring it, I'm going to write it as 2 squared. So this indicates your method. I can tell what you're doing for two reasons. First of all, and more importantly, actually, you have y prime of 2 on the left, but then every value that appears in here shows up from the table above. And if this were a free response, the reward for that is you're done, right? Multiple choice will keep going. That's 2/3 plus 24 over 4. And at this point, we have a complex fraction. So we can lick them over lick them by multiplying by what? 3, right? The LCM. So when you distribute in the top, you get 2 plus, what's that going to be? 72? All over 12. So you end up with 74/12, which that also simplifies. There's a 2 that's common for sure, so 37/6, and then 37 is a prime number. So a little bit of arithmetic on the back end there. And that's not the only way, remember, to clean up a complex fraction, but it is the quickest, fastest, most efficient, most fun way. It brings us Hygge, I guess. H-Y-G-G-E? Yeah, H-Y-G-G-E. Okay, letter G. Go ahead and do G on your own. Go ahead and set it equal to y first, though. What's that? Yeah, I guess not intentionally, but we'll go ahead and do G. Go out of order sometimes. The alphabet is just, the order is just suggestive, right? I mean, if you want to sing the song another way, that's fine. D, P, M, C, Q, F, E, D, R, A, F, I, S, T. Federalist. Test today? No. Oh, but this week? Oh, no. Oh, I was going to say good for you for doing things not last minute. That's awesome. But you have a quiz. So still good for you. It's the last week of the 9 weeks, of course, so maybe tests or quizzes or assessments in every class. When you bring it to the top, what happens to the exponent? Yep, an easy thing to quickly overlook. Oh, see, you have 2 layers there. So when we write it like that, that's the same thing as the whole thing squared. So what could you do here before you? Oh, are you already taking the derivative here? You got a -1 in front. That would be y prime, but what can we do here with the 2 and the -1 first to get rid of a layer? See, because that's written in condensed form. So let's just say the whole thing is 2. Then there you go. And now there's only 2 layers. Yeah. So I would. We talked about this yesterday when you weren't here, but it would be easier to, because you have 3 layers like this. If you combine those before you take the derivative, you only have 2 layers. Yeah, which makes it a lot easier. Because then you're missing a layer here. You would still need to multiply by g prime. Again, the chain rule, adding parentheses, and being very, very careful when you're rewriting it can save a lot of errors, missing whole derivative factors. So if I rewrite this, remember this is the same as 1 over g of x quantity squared. The calculator writes it like that, but we just learned that that's not the same in real math, okay? So you need another set of parentheses around there. So that's to the second power. That's the expanded version. Now, you could use the Hody-High rule, but as we mentioned, because there's just a constant in the top, you probably want to bring it to the top and use the chain rule. And we did it yesterday, too, when there was an x in the top. When we were factoring out least powers, we just used the product rule instead of the quotient rule. So now I have two layers. Now I'll go to the derivative. dy dx, blob to the negative second is negative 2 blob to the negative third power. We subtract. And then times the derivative of the inside layer, the derivative of g is g prime. And again, if you want, just to be extra thorough, the innermost layer is x, right? What would be the derivative of x? No, 1. Okay? So you don't need to do that. The only time you really need to treat the inside function as its own separate function is if it's something other than x. If it's a variable function, something other than x, because then it generates a non-trivial derivative, something other than the identity element of multiplication. All right, so now, because I'm going to use it, I am going to take a little bit, one more line to clean it up. That's going to be negative g prime all over g cubed. Now, you could write it like that if you want. We haven't plugged anything in, so you can just refer to the names. Notice g prime kind of looks like g to the first. If you want to put the of x, then certainly, by all means, do that. Or if you want to, instead of calling it g cubed of x, because we're going to use it, call it g of x quantity cubed, which is the easier version if you're going to use it. Now let's plug in our 3. So next column for me, dy dx, evaluated at x equals 3. And let's see if we could do this one by plugging in straight from the table. The negative 2 is a negative 2. But now I need g prime of 3. G prime of 3 is 5. All over g of 3 cubed. And g of 3 is negative 4. So the quantity negative 4 cubed. So that's fine. You could do it that way. You don't actually have to show, g prime of 3, g of 3 quantity cubed. Free response, we're done. Multiple choice, we keep going. That's negative 10 over negative 64. Of course, the negatives divide out, but there's also a 2 that could divide out. And we get positive 5/32, or 5/32. Okay. So yeah, we jump to G. I think you get the idea, right? Should we finish them up? Yeah, we probably should. Practice, practice. Bless you, practice. All right, so this one is what? Composition or multiplication? Composition, right? Because we read that as f of, not f times. So it'll be the chain rule, nothing to be rewriting. So we get y prime is f prime of the inside function times the derivative of the inside function g prime. And then, of course, times the derivative of x, which is 1. So that's actually the chain rule as I taught it to you up above. That's actually just restating the rule. So now when we plug in, since we know some stuff about f and g, we can plug it in. Now notice, in this case, you can't just say f prime. You have to put the of x. Because if you just said f prime of g, that doesn't look quite right. So we'll go back to putting the of x. And now I'll plug in a 2. So y prime of 2, you can kind of use function notation. This is going to be f prime of g of 2. I wouldn't do a composition in 2 steps. But g of 2 we can go ahead and write down. It is 2 times g prime of 2. We can write that down. It's negative 3. So again, not dot negative 3, but parenthesis negative 3. And now we're not done. Now we need to evaluate f prime of 2. So if it's one of these composition problems and you find that you don't have a number in the table that you actually need to evaluate some function, it probably means you did something wrong. F prime of 2 is a third. So it ends up being a third. Come on, there we go. 1/3 times negative 3. And then you could stop there on a free response or keep going, call it negative 1 on either a free response or a multiple choice. Questions on that one? All right, next one. We got 2 more to go here. Y equals that. First step is to what? Probably rewrite it, unless you're so well practiced already that you don't need to rewrite it, which would be fine. There's no rule saying you have to. You can just look at that and say, oh, that's the whole quantity to the 1/2. So I'll go back to dy dx this time. 2 layers, right? So 2 layers means 2 factors. The outer layer is 1/2 blob to the negative 1/2. We write down the blob times the derivative of the blob, which is f prime of x. And then, of course, times the derivative of x, which is 1. So again, because I'm going to use this and I have either a negative or fractional exponent, I'm going to spend the time for one whole line of cleaning it up. I'm only left with f prime of x on the top, and at the bottom I have 2 square root of f of x. It's a lot easier to use and evaluate when we don't have negative exponents and we don't have fractional exponents. And now I'm going to plug in a 2, so let me start a new column. dy dx evaluated at x equals 2. So again, when you're using Leibniz notation, that's how you do it. F prime of 2 is a third. I'm going to use the slanted version here. And then 2 times the square root of f of 2. F of 2 is 8. And of course, if this were a free response, we would be done. Multiple choice, we'd keep going. We have a couple of options. We can either eradicate the complex fraction first or simplify the radical. I would probably go with the fraction part first. Multiply by 3 over 3. So if you multiply in the top, 3 times the third is 1. And at the bottom, you're left with 3 times 2 is just 6. Now, there's no reason why we can't simplify the square root of 8 right here, right? We do as much as we can per factor per term in each step. The square root of 8 is what? Simplified. 2 square root of 2. Good. And so our final answer is 1 over 12 square root of 2. Now notice, the only time I really write diagonals on my fractions are sometimes like this, when it's in a fraction itself, or when it's in an exponent. In general, stay away from slanted division bars. Is this the same thing as 1 divided by 12 square root of 2? Yeah, very good. These are not equal. The one on the right is actually equal to the square root of 2 over 12, because it divides by the 12 and then turns around and multiplies by the square root of 2. So very, very important. If you wanted to write it on the diagonal, you would have to do 1 divided by parentheses 12 square root of 2, which is kind of what the old version of the calculators required you to do. So now with MathPrint, they have the horizontal division bar. So be careful using those slanted bars. Do we have to rationalize the denominator? No, in general, we don't. So that very well could be a multiple choice answer, but we should also be prepared to rationalize if the multiple choice answers don't have square root of 2 in the bottom, or it doesn't match up. So that would become the square root of 2 all over what? 24, right. Radical 2 times radical 2 generates another 2, and the 2 times 12 is 24. So either one of those are correct. All right, any questions so far? Brim up or brim down? Down, okay, good. The next one, the last one. Do it yourself. Go. Let's get you started on your own. Remember, rewriting in the beginning can be the key to establishing an easy, enjoyable Schwiege process all the way through. If you're going to rewrite it, there's probably the way you want to rewrite it with all those parentheses. No, you could also use brackets. Sometimes those stand out a little bit more. Or notice how I kind of wrote the inside a little bit smaller just to kind of show that it was the inside function. All right, so we walk up to the problem. The outer parentheses are like walls through which we cannot see. So that's the rule of the derivative that we start with. Of course, the left side is dy dx. And now we have blob to the 1/2, which is 1/2 blob to the negative 1/2. Now, everything else on the inside, you could either write it exactly how you have it, or you could put it back in the original format. Because I'm going to use it, I'll go ahead and keep it in this expanded version. All right, so there's the outer layer, and now I go inside. Do I need parentheses? Yes, and sometimes you don't, but in general have them. In this case we do, because we have more than one term. So you have to unpack the boxes as you get to them. The first one is going to be 2 times f of x to the first times the chain rule. The derivative of f is f prime. And then plus the next box, 2 blob to the first, that's g of x, times the derivative of its inside function, g prime of x. Close that, close that. Unpack the boxes as you get to them. Now, because we're going to use it, we can simplify. We get dy dx equals, you could take this 1/2 actually if you want, and you could distribute it over here, or factor the 2 out from the last factor group and divide it out with the 1/2. So that's going to end up just with f prime of x times f of x plus g prime of x times g of x. All over the denominator is going to be the square root of f of x quantity squared plus g of x quantity squared. Okay, that's the last problem for here. We'll do example 8 tomorrow, and we'll be done with the chain rule. Your test is on Thursday, so tomorrow we'll kind of play it by ear. Maybe finish the notes and work some practice problems from old tests. Tomorrow's also pink day, so remember to wear pink. Pink, pink, pink. The color, not the musical artist. Have a super day.